Hi, nice to meet you again, I think. So, we already have occasion to present our agency. So today, I will just go through some more details and additional slides I've added, and also some services that we just had an overview last time, just to better fine tune and understand how those services can be interesting for any organization that would like to, let's say, improve their digital presence and the way they use digital on a strategic perspective. As you know, the difference between a web agency, a digital agency, a growth agency is not only regarding the channels they are using or the tools and the assets they are creating, but by my point of view, the most important difference is the approach and the purpose every different company has. There is no better or worse company or approach. It's just a matter of how you want to deliver your services and which needs you want to satisfy for your clients. So, as you know, the web agency started, and there are a lot of web agencies where the focus is improving just the communication a company has through the web channels and online. Maybe widening the services also not only to the website itself, but also to the social media channels and sometimes digital PR. You know what digital PR is? So digital PR is the PR means public relations, but through digital. So as you know, public relations are very important for many companies in the real world, let's say, so on the offsite perspective. It means, for example, inviting journalists and press, having press tours, influencers, so sending press release or any other news, corporate news to newspapers, magazines, in order for them to spread the word about your company. These are the public relations, event fairs, and any other, let's say, opportunity a company can have to get in touch with direct clients or stakeholders. For example, a company which works on the construction industry can meet architects, engineers with specific event or giving them new contents for their job, for the innovation in the construction industry and technologies, creating this kind of event. Digital PR is, let's say, the same, but through digital. And it's very, very important when it comes for a website to be listed in the in the search engines. Digital PR, let's say, is the translation of the word of mouth in the real world. So the more websites that are not yours, but from third parties that are talking about your website, for Google and the other search engine means you are well known, you have a good reputation, you are impacting your industry. So the positioning in the search engine result page goes up. So digital PR is very important. And this usually is the main area for the web agency. Digital agency put more services on the bucket, on their proposal, adding not only website, social media, and digital PR or SEO and SEM services, so search engine marketing, search engine optimization, but also mobile app, digital strategy, so how you can tackle the market for digital, not only how to be available 24 hours with your website. And sometimes also they do outsourcing services for company to manage their channels. So to manage their social media channels, to send newsletter, to manage all the digital properties of a company. This is where the digital agency stands. And usually they also provide coordination with other vendors like photographers, video makers, and stuff for the website or for the digital channels. It's like, the advertising agency, the normal, the traditional advertising agency for the digital channels. And then the growth agency comes, which is, let's say, a mix of what a web agency, a digital agency do, but together with the mix of strategies and technology for increasing the business of the client. So usually the web agency goal is to create a good presence of your client online and somehow, sometimes getting results. Digital agency is also on the communication perspective, on getting awareness, consideration, on raising interest in the market across different channels. I don't know if you already know about the owned, earned, shared mix of channels. Owned are the channels, again, owned by a company, like, the website, their social media profiles, the mobile app. So all the channels that they can directly manage, influence, and in case switch on or off. The earned are those that are not managed by them, but by third parties. And those third parties give to the organization specific areas, like, directories, third party social media profiles, magazine, forum, blog, any other. Shared are the channels that are created, managed, and updated by the users. All the contents created and generated by users. And then, of course, you have the paid channels. Paid channels are those that Google and any other huge advertising network make available for any company to advertise. So you have a mix of 3 to 4 different approaches. And this is where the digital agency goes. And then again, the growth agency. Sorry for this long introduction, but I want you to understand also why going through our presentation, you won't see creating website or creating digital campaigns only. So growth agency purpose is to understand the strategic, the business goals of the company, not the communication goals. When you deal with a digital agency, usually you are asking for the strategy and the goals of the company in terms of communication. The growth agency deal with the clients for strategic goals. So the business goals. For example, a company wanna enter a new market. This is a business goal, right? Or they wanna diversify their production, their services by launching a new product, but not only launching, selling, of course, the new product. So digital communication agency usually ask for the goals of, I don't know, awareness, or how many downloads, how many visits, and how many new users or a newsletter subscriber you want to get through the launch of the new product or in the new market you want to enter. While the growth agency asks about how many deals, money, sales, and any other KPI which is relevant for the business. Okay. So let's say that the growth agency mix consultancy and strategy on the organization of a company together with the consultancy and strategy on the digital perspective. I don't know why the presentation doesn't run. Okay. As an agency, you know that, but by my point of view, any company in the services and consultancy industry, main asset are people. We work with technologies, but the most important asset for us are our human resources. And we believe the same also for any other company, unless AI will replace some job. But so we will take care of the AI at that time. But now we think that every time we work either in our agency then to the client organization, within the client organization, the most important thing is to get the point of view, the perspective, embrace the pain points and the expectations of the persons, of any person. So we want to inspire people to embrace the change, because usually every time you want to change, there are some, hurdles, you need to change the way you usually do something, which is not very easy to do at the beginning. You need to have your own, let's say, goal. And because the moment, just because the company say you need to go that direction, doesn't mean you are thinking about that direction as the good one. You are not convinced about the new road. And for a company, the directions need all the team involved. Otherwise, the project will fail. The most important or the most common reason a project for changing the way the company approach the digital sphere is because of people. So you have the saboteurs, so people which is waiting for the change, and when something is not ideal, start fighting against it, okay? And then the project for sure won't be a success. So the first thing is to think about how the technology will impact the daily process in the company, because digital usually can be seen as a threat, as an issue for many employees, because of the technology can control, maybe, if, of course, the company doesn't communicate properly and doesn't approach in that way the technology. And you know that every person that think he's controlled by, not only by your boss, but, which is normal, I mean, but also by technology, by any single act you do through your daily activity on your laptop is controlled. You are evaluated about, again, growth means revenues, leads, sales. So everything is tracked by technology. You can be worried about this. So a very important thing for us is to let people understand that we embrace digital, but we should stay human and put the values before the technologies. And then the way you use technology is driven by your values, okay? This is very important because it's the very first thing usually we did with, okay? That's why we want to propose as a digital transformation partner, not provider. The provider, you ask something, they deliver. We don't want to be a vendor like this. We don't want to be a supplier. We want to be a partner of the company because we want to be active. We want to wear the same, the rest of our client, of their employees. We want to be part of their team. In this way, we can propose how the technology can proactively and be beneficial for the client. Alea is an agency with a team of over 30 professionals, divided by 4 different areas. And these 4 areas came along the time, because our agency as well, it's a private company, and it's evolving over the time, how the market evolves, how the client needs change. At the beginning, when we started 24 years ago, we started as a web agency. That time, digital meant web, that's it. And growth agency was something not predictable at that time. So we started as a development and system integration, the third box. Why? Because we worked together with the, I named before, let's say traditional, or let's say offline communication agency. So they have the clients, they have the ideas, the strategy, and that time the web was only, you know, the something to put together in the mix of the media at that time were used the most. So, you know, brochures and any other printed materials. So we started with the web only development. And even the system integration wasn't something requested at that time, because the website was a silo, just a channel working itself online. That's it. No other communication with other softwares, with other processes in the company. That's it. You have a website, yeah, we have a page with the picture, usually the picture, you know, of the external factory, couple of pages, that's it. And then, of course, the web increased. And we understood that the way the web communication changed was different, and also the expectation of the audience on the web were different of the expectation and on the way the offline communications goes. So also the creativity changed, because you know, website that time started static, let's say, but then animations and videos and other things came that, of course, in the traditional printed material you don't have. So we started also combining not only the development, but also the creativity. So creating our own layouts and design. And then we realized that one of the problem we faced was getting the contents. But today is the same. Today is the same. One of the most important thing is getting the contents, and getting good contents. That time was very, very difficult, because no one prepared contents specifically for your for his website. So they just gave you the plan, brochure, price list, pictures, everything was available. Okay, put together, create a website. In the best scenarios. In the worst scenarios, you did interviews, you ask for pictures, you did you shoot pictures and stuff. So we, let's say, created the second business unit. So development first, creativity, and then content as a second business unit. And then we started having, because of e-commerce came, social media came, we widened our development expertise. And then we started, let's say, approaching the world digital scenario. And then let's say that from web agency, slowly, we approach the market as a digital agency. And digital agency foster us to think about strategy, how to better communicate, how to create a strategy, a good mix across channels, markets, and stuff. And then we started working on the strategy, but together with the production, together with the creativity, it was something together until I think 6 or 7 years ago, when we realized strategy was something very important for which a client can pay just for that. Even if you don't proceed with the other part of the project, with the creativity, or maybe the creativity is outsourced and the developer maybe is outsourced again. So we started proposing just strategy. And from there, we realized that the new 4.0 model that impacted, the industry and the production sides was an opportunity also for the office, let's say. So for marketing, sales, HR departments, quality, and customer service. So we started thinking about creating a new area, so the strategy and innovation for the digital transformation. And then we combine not only our own web and mobile development, but also adopting technologies ready to the market, like HubSpot, Salesforce, and any other, let's say, technology for the 4.0 model. So we combine strategy, creativity, development, but then very recently, 2 years ago, during COVID, we understood also that customer service was not enough. As any other company, usually the customer service is something that you must deliver, because you cannot, of course, just sell something and then you don't want to answer to any issue after the sale. But we understood also that it's very important to make it clear to our clients, if they are getting the results we are promising as a growth agency, but also to let our employees, our specialists, our professionals, to continuously monitor if these results are coming, in order to better deliver new services, fine-tune what we are delivering, and of course, be aware of any issue before it's too big to remediate. Because at that time, it means the client, of course, the customer is gone or is gonna go, okay? Then we created the fourth and last area, the customer success. Again, not service, but success. We don't wanna just support our client in case of need, but we wanna them get results based on our strategy, creativity, and development. So we want to measure the way they get success, the way they get results through digital data, reporting, and of course, even a customer service in case they need. But before, it was just customer service. Okay, so that's our story, and how we ourselves are an example of how the company evolved along the time. So 24 years ago, we didn't, let's say, foresee that along the time we will add new professionals that even didn't exist at that time, for example. So no one expect a social media manager could be a new job role, right? 20 years ago. And today, maybe we are foreseeing that there are new job roles coming, and maybe some other job roles we are not aware about. But as a company that wanna not only, let's say, survive in the market, but have their own positioning and a healthy company, you always need to take care about how the market is evolving. And customer success is crucial for this, because together with sales, customer success is a client-facing department, right? But sales is not there because it's not, let's say, a business area which provide, specific turnaround. It's something that, of course, you need as the HR office or the marketing and other functions in the company for make it effective. But the customer success understand how the market is changing. And of course, we have also created a R&D team across the 4 business units to get directly from the specialist perspective, because they are dealing daily with new technology, new issues, where the tech stack is evolving, in order to understand if we need to revise something, to introduce new technology. The model is a mix of internal and external processes and areas of activities. So if we can see the dotted line here across that divide the channels, it means that we work with channels that communicate and go on the market, and other that are used by the employees of our clients. And then we perform actions and strategies to the market to achieving clients of our customers. And internally, we work and innovate the processes that the employees of our customers usually perform. It's a mix, and even that model is something different from the model a web agency usually work with. Usually, web agency are looking at the market only. So, and also digital communication agency usually. So the focus is, I need to create a new website for the market, for attracting new clients, entering the new markets. You will measure by this kind of KPI in terms of impressions, traffic to the website and stuff. That's it. While we usually give a lot of attention to what happens when this activity we perform to the market comes back to the company internally. So if they are impacting, how the results are managed. I think I've already talked about, but it's a very easy example to do. When a client of ours launched a lead generation campaign, we work on that campaign, we get good results, good performances. However, when we did a quarterly analysis of the results, we've asked to the client, it looks that our campaigns are impacting on your business, are good, are giving good leads, and hopefully you are getting results. But it wasn't. Why? Because the way internally they follow up, they manage these leads was not optimized, even was not structured. So any sales rep worked their leads autonomously with their own processes without any structure flow. Then results were not as those expected by the client. Hopefully, because of having us promoted that quarterly report meeting, we understood something went wrong, and then we proposed to use a CRM, which impacted, of course, their processes, the way their employees, their sales rep usually worked. And it was a real challenge in terms of mindset. Because again, sales rep usually they have usually a high self-reputation because they know how to sell, maybe because in the past they get results. So of course you cannot teach to any sales rep how to sell the product they know, but you can support them to take out the most from the technology, to support them on reiterative actions, on reminders, on being aligned, on follow this procedures, on again get benefits out of the technology. Then that was the first challenge, and then result came, and starting from a campaign, a business area, then we grow with the clients, with the additional campaigns, additional projects. The 6 main area where we work in a ideal scenario are human resources, administration, communication and marketing, new business and sales, assistance and quality, and data integration. Of course, as you can imagine, we started with the communication and marketing, of course, because it was the very first area we worked since our beginning, Then new business and sales was immediately the second area we started thinking about how the 4.0 technology can impact and change the way usually a company work. Then we started thinking about remote selling, about CRM, about sales automation, about digital internationalization for the new business. And then the assistance and quality, because usually customer service for any company means also assistance and quality assurance. When a company is well structured, usually if a request from a client detect or means there is an issue with the product, usually the customer service alert the quality or the production or the product manager to let them know there's this issue to fix. And maybe that the same issue can impact or potentially other clients that didn't experience that issue so far, but maybe they have. So also the way you automate and track and transform your assistance and quality department can be very important. Then we came to the human resources. So how to adopt new technologies to, for example, not only have a smarter relationship with your employees, but also how to attract talent, for example. One of the most important challenge now for any company is, in Italy for sure, hiring new people. There is a very, very important gap between the requests for, in terms of quantity, I mean, of specific professionals available and how many universities or the, let's say the job market offers. So there is a huge competition, and again, many companies need a strategy for attracting talents. And then, of course, they will proceed with the hiring journey. So human resources is not only the way you manage your current resources, but also, first of all, the way you do attract. And then data integration. Data integration is also very important in order to overcome the issues you usually have when all these 5 departments HR, administration, communication and marketing, new business and sales, and assistance and quality usually work with their own softwares, which are not sharing information, very important for the business. So data integration now is crucial, together with, of course, the data analysis. So what I mean for digital transformation in the human resources, I mean, again, starting from the recruitment, having some clients are asking us digital campaigns for recruitment. That is something that 2 years ago we didn't propose, even didn't expect someone can ask, right? But again, as a marketing campaign, even a recruitment campaign needs processes, needs technologies for, of course, activating the campaigns, getting the leads, and then proceed with the steps before the company propose a job. But then let's say that the candidate accepts, then another journey starts, because maybe you have 1, 2, 3 months before the newcomer can start with a new job, because they are leaving their current company, or maybe they are still at the university finalizing the degree, the graduation. During this period, you need to still have a communication, active communication, and prepare for the onboarding in order for the new employee to be part of the company immediately. Not only in terms of know-how, this is something that, of course, need time, but in order to understand services offer, the mindset, the values of the company, and the welcome the company can give you. And then there are many other innovations on a daily basis for the attendance registration, scheduling shifts, holidays and permits. Many companies are asking their employees to, fill up paper for asking permissions or holidays, while you can digitize everything, of course, which usually turns into a benefit for the HR department, that they will lose less time on collecting papers and entering data into their HR softwares. And then they can use that time they save for what? For caring the employees, for having one-on-one meetings that you need to track. You know what are one-on-one meetings? One-on-one meetings with employees means understanding where you do stand, which softwares, know-hows, or information you need to improve, what kind of training courses you would like to do or you need to do. Having a one-on-one relationship, as you did at the first time for the when you were a candidate, but then you want to grow, right? All of you want to have your own career, right? And the moment you have a company which gives you on a quarterly basis, for example, a one-on-one meeting to assess where you do stand now, which result you achieved in the last quarter, what's next, you think that you are not an employee, but you are a person that is growing that company, and the company consider you a real resource, not just an employee, right? Gives their time. But this usually is something that is not on a mindset perspective as an issue, but also on a perspective of having the time for doing this. And monitor. And then also another important thing we do for the human resources is creating the self-service areas. So an online restricted area, individual area for any employee of the company to enter for getting information about their payments, about their permits, about their holidays, and any training or procedures they wanna consult. So everything as a self-service portal. Documents is something that many companies are asking for. Of course, big company already have this in place maybe since 10, 20 years. But small, medium enterprises that you know are the 95% of the Italian companies are approaching that kind of dealing with human resources right now. Same is for the administration, where usually we work on the order to pay flow. What is the order to pay flow? It's the way usually companies sell their products online. We want to make them more effective by having a unique flow, which is not something easy to do. So every time, for example, you order something on an e-commerce, big e-commerce have everything automated, of course, and the flow from the order to the payment you do on the e-commerce, for you, it's a seamless flow, right? Usually for small companies, involves 5 to 10 different softwares, procedures, persons. It's very fragmented and time consuming. Human errors can come. So usually we work on that side, and also to make the business paperless. So signing contract with the e-signature rather than printing, sign, scan, send, for example. So how to manage the paperless business in a company is, of course, well known, but still not yet adopted in Italy from the majority of the companies. An example?
Yeah, what companies really, what small companies do when you buy something from that not.
Well, it depends if they are delivering to you just a service, like, you know, an online insurance, for example, which of course now it's 100% automated. Or if they will deliver to you a good, which maybe is not yet ready. Because it depends. If it's a service, usually you can even get just the order in place and then the service is delivered in a second step. For example, I don't know, you buy from us a digital audit. You pay online, everything is very quick, and then we will deliver maybe in 1 month with you. So we will get in touch with the company, we start assessing, have interviews, creating, delivering. Online insurance create the services immediately. You get at the end of the payment of the procedures, you get the service, right? So the system automatically creates the service you are paying for. When you are buying a good, like, I don't know, a pair of shoes, usually they are already available, of course, are on stock usually. Or can be that they are not on stock, immediately available, but they've been already produced and maybe in another vendor has in their stock. So the shop sells to you a pair of shoes they can have, but not in their stock currently. So there is the supply chain. They need to get the shoes from another vendor, from another warehouse, the logistic for the vendor to pick up the product, ship the product to him or directly to you. Drop shipping, you know what is drop shipping? Drop shipping, for example, it's the way you can, let's say, make the transaction faster. So you bought the shoes from my shop, but I'm just reselling the shoes from, I don't know, the producer. The producer can ship to you directly by placing the label of my shop. So the product doesn't come to my warehouse and then I ship to you. So 2 shipments, 2 costs, more delays, right? So drop shipment is you order to me, I place the order to my vendors, the vendors send it to you. This is, for example, the way many companies are innovating. The benefit of this model is that my shop can sell 10,000 products without any warehouse, right? I'm just pushing on sales and marketing, while the logistics, the production, no, the customer service is on me, of course, is on my vendor. In Italy, but across Europe, usually this is the model for any online shop for technology devices, laptop, smartphones, and stuff. Usually in Italy, for example, there are 4 to 5 big, huge distributors with thousands of square meters of a warehouse. They give to any online shop their price list automatically, of course. So you can open your online shop without having any product on stock and even any warehouse for you. You just sell their products and they take care of everything, production, logistics, and stuff. For example, this is drop shipping. But drop shipping means data integration, system integration, the data integration. We had a client, they sold the company now. They innovate that business model, working not only with one big distributor, but with 4 distributors of technologies. They put together the 4 price lists where you know that the SKU, so the unifying coding for the product, Samsung, this model has a unique SKU. Okay. The client combine those 4 price lists with the same SKU, and as pricing is dynamic, because depending on how many any distributors has on stock of these products, the price can goes up and down. Okay. So my clients automatically show always the lower price available on these 4 vendors with their margin. So they competed always with the best price, right, in the market, because they always get the occasion for having the lowest price across 4 different vendors. A very smart idea. And then they sold the company. But a lot of marketing was needed and also data integration. That's it. So their company was to market and customer service and data integration. That's it. And even with the customer service, think about customer service not only after sales, but even pre-sales. For example, how many times maybe you are dealing with live chat or chatbot on a website for getting more information about something before you buy, right? Usually it's the customer service answering to you. So customer service can also be part of the sales funnel for a company. So you understand how growth agency and revenue operations, as US name now, the mix of marketing, sales, and customer service, should work together, should share procedures and data. This is very important. And another example, if you go far on the chain of the production, is when you order something and the product is not yet available. You can order a Tesla online now, right? So you can buy the car. When you buy the car, usually for Tesla for sure, is not already on stock. They need to create that car with the options you choose, right? And they don't have 100% of the production of any single part in-house. They have their subcontractors. Of course, everything is automated at that level. But that's just an example for you to understand what is behind the order to pay procedure. For the client, it's very easy. And you pretend 3 steps, maybe. That's it, right? Choose, pay, get confirmation. That's it. But behind all of these procedures, there are a lot of systems involved. Even when you choose the product, live, the system should check if it's still available, if the price is still that one, or maybe changed. So there are hundreds of procedures involved. Regarding communication and marketing, say our services, first of all, try to change the way the company approach marketing and communication. In the majority of cases, companies wanna present and talk about themselves. I'm good to do this and that. I can give you this and that. You can buy this and that, right? While by a customer-centric approach, this way of communicating doesn't work. So usually we wanna convince our clients to change the way they approach the marketing and communication, not talking about themselves, but talking about their customers, asking and understanding the needs of their customers and how, or the expectations of their customers. And then you can provide useful information and hopefully sell your products at the end, because people needs support, needs information. You know, every time you buy something, you are along the buyer journey. You hear about that? The buyer journey usually is divided into 3 steps, 3 phases: the awareness stage, the consideration stage, the decision stage. You want to buy a car or a bicycle, a helmet for ski, okay? Or you are an expert, then it means that you are already aware about your needs. Otherwise, first of all, you need to understand your needs. For example, my son 3 years ago started doing inline skating. It was something new for him, and of course, even for me. I didn't know nothing about inline skate, you know, wheels. There is a world of wheels, frames, and shoes, and technologies, and carbon everywhere. So at the beginning, even if you get a special discount about that skates, you can't accept, because you don't know if it's the right one for your son, right? Or for you. That's why the right moment, the right channel, the right contents matter. Otherwise, the company is offering me the product at a very discounted price, then the company is reducing their margin, but I'm not ready to buy. Why? Because I'm still at the beginning of my buyer journey. So first of all, I need to understand, to be aware about my needs. Okay? Then I need to consider what kind of product or services can satisfy my needs, right? So maybe I restrict, I don't know, I understand what kind of inline skate my son need, 4 wheels inline, first of all, not fours, in parallel. And then with lower shoes, because it's most performing and ideal. So you restrict the product. Okay, then you need to consider which product you want to buy. And then you evaluate trends, and you start asking about or searching for reviews, right? About the brands, about the products. And then you restrict about the budget you want to spend. You can spend 100 to 500 euro for one product. So you restrict and you consider the opportunities. Then you shortlist maybe 2 or 3, right? Then you're moving from the consideration stage to the decision stage. And then at the end of the decision stage, of course, you buy something, right? So depending on where you are on this journey, you have different perspective, different needs, different information you are asking for. Okay? So if a company understands this, then they can attract people at the beginning of the journey, not at the end. Okay? Usually, also digital marketing campaigns are focused on the last part, sales, promotions, and marketing just for I'm selling this product. Okay, but that product, how can satisfy your needs, your expectation? So you need to go back to the customer-centric approach, depending and understanding where your client is along the journey. You are maybe, I don't know, 20, 25 years old. So maybe you are leaving your house, or you are looking to a university, you are choosing the university, or even before the university, the city. Or it depends. You started thinking about the city, where to live, or the university, and then the city where to move. It depends. Different approaches, but you are a similar target, right? Same needs, finding a university or next step for your study and your growth, right? But different step on the journey. Maybe someone of you already decided the university courses, I don't know, engineering, but not yet in which city or in which university. Others are still evaluating the scenarios. So you understand that doing this, you can fine tune with the clients. Usually it's not this way, it's vice versa, but this can impact. Then, depending on the buyer journey stage, channels can change. Usually, when you are searching for reviews, it means that you are not at the awareness stage, right? You are at the consideration or at the decision, because you want to understand the experience of other users with that product, university, and stuff. So we can use these, or we can advertise on these online portals for reviews with specific messages. Okay. Why we need to use other channels for the other stages. So this is the customer-centric approach. Then we start with the strategy, understanding the buyer journey for the client, the touch point they will meet along the journey, how we can target and segment the audience. Again, the customer journey. Then we do a content audit. So we want to understand what the content the company can deliver to the users in the right channel, in the right step along the journey. Usually everything is at the end, the decision stage. Many clients now are moving a step back. For example, again, for the inline skates, I'm not yet ready for buying, maybe. So I'm not attracted by discount code or any other promotion, but maybe I can be attracted by ebook, 10 different, I don't know, suggestions or things to consider when you choose your first inline skating product. This is worthy for me. Then I can give my personal data, my email for downloading that content. When the company has this information, then they can start nurturing me through a strategy in order to bring me along and hopefully sell me something. Then the lead generation, for example, comes this way, not just for selling, but before for having personal data of a prospect, giving them valuable information and content. How many of you maybe are experiencing that kind of downloading useful assets? You fill the form, you receive back a PDF, and then from there, you will see the same ads in Facebook or any other social, and then you will receive an email, and after 1 week, another email, or maybe a WhatsApp message. This is the strategy after the lead generation. And then data enrichment, which means the moment you get information from a client, how you can collect more information of that client. Customer marketing, which means is very important, the new business and having new prospect and new clients, but it's even more important to communicate and market existing customers. Statistics mention something about the cost of acquiring a client, new client is 6 times higher than keeping those you already have. Jeff Bezos, you know, the CEO of Amazon, always mention about his obsession, not for competitors, but before he was the leader, of course, when he was growing, he was not obsessed about bigger competitors than him, but about the way he could keep their client base and then growth. And by the way, that was their strategy, right? Usually, many clients from Amazon are not buying because of the price is the best one online. It's not always the best online, right? But you buy because you have an excellent customer service, delivery time are very quick. So they give you a customer experience that no other can give you, and trust on them. And then dashboard reporting to understand the impact, of course, of your activity, and compliance and privacy, which is, of course, something very important. And I don't know if you hear about the cookie-less marketing. So the way things will change now, because of users are, of course, more worried about how a company can use and share their data, personal data, right? So Apple started by reducing the way the operating system can get personal information from the user without their permissions. And then GDPR in the European communities ask your permission before getting this data or before moving the data of a client in the US. So there is a lot of attention on the privacy. And next step is that the behavioral marketing will be difficult because, you know, Facebook, for example, get a lot of information about your interest and preferences, but any, of course, social media. Or Google knows about your interests, because exactly knows if you use, for example, Chrome, they know all of your past navigation. And they know, for example, that because you are browsing dozens of websites about how to choose an inline skating, then you are at the beginning of that buyer journey, and they can sell your cookie to, I don't know, rollerblade for them to promote you the product. They know that last week you visited 10 different websites for university in the same city. Then Google knows you are on the consideration stage for that. Okay, so you understand that every one of us are along, I don't know, 10, 20 different buyer journey. Some buyer journey, let's say, lasts maybe 1 week, other 1 year. You want to buy a new house, is something that maybe you don't close in 1 week usually, right? So the way big tech can sell this behavioral cookie information is changing. And now the technical term is third party data. Third party because, again, Facebook and third party can sell to you their data about their users. This is something that in the future won't be possible anymore, or very, very reduced. Okay, because now the logic is they can do until you tell them don't do. Next step is they can do only if you allow them to do. Okay. So the way you will market in the future will change, and technology will be very important for you to record all of your own channel data and take out the most from there. But I don't want to be too much boring, but this is just an overview of next steps on the digital marketing. Similarly, on the new business and sales, because as I told you, sales and marketing and customer service are very close each other. So, for example, on the new business and sales, we work on the way we can automate processes regarding the sales. First of all, we want to understand the structure of the commercial department, how they work and follow up on prospects, how they process their sales, the procedures, what kind of supports, and how they align with marketing. This is a very, very important thing that 99% of companies don't do. And how they can sell remotely, and how they can go paperless, as I mentioned before. And of course, even for new business and sales, is very important the compliance with privacy and dashboard and reporting. The third area is the assistance and quality, fourth. So how company are getting customer requests through ticketing, through live chat, through social media. You know that now any user has multiple choices for contacting companies, right? Directly to social media, WhatsApp, instant messaging, website, online forms, a lot. The issue is that for a company can be a mess. It's very fragmented. So they don't remember that maybe you open a ticket, then you deliver additional information through WhatsApp for the ticket, and then no one answered in 2 hours, then you gave a call to the customer center. So 3 different pieces of content delivered by the users, 3 different databases, 3 different employees maybe handling this information in silos. So we want to overcome this issue, and we want to revise the way companies manage the customer request, how they track and deal with the complaints and non-compliances. Non-compliance, you know, in the certified quality perspective, is every time something went wrong on a procedure. because of something, again, can be due to technology, to lack of information, to human errors. So fixing an issue doesn't mean that issue can reoccur in the future. Another very important thing is the crisis management, but this is more on a strategic perspective. So what happens if a company is impacted by bad news? By, you remember Tesla, I don't know, 3-4 years ago, the first time someone died because of the self-driving feature for Tesla. I don't know if you remember. It was very impacting, of course, and that affected the company in terms of reputation, of reliability of the product, and the crisis management was very hard for them. Of course, that kind of issues can occur to small company. We are working with a local company which produces and sell sofas, okay? Sofas everywhere in Italy. The issue is that 2 years ago, a specific, let's say, gear of the sofa internal, was damaged because of their vendor, their subcontractor. So these gears was not good, and after a while, the sofa was broken, was not comfortable to sit in the sofa. So many clients started publishing on the Facebook page, Instagram profile, their own or the client one, or also in the Google Place page, those issues, those problems, these problems, and then we prepare for them a crisis management procedures in order to avoid and, of course, answer and immediately give feedback to those users, satisfy them, replace the product, ask them to let other users know about this, and then revise their reviews, and then send an email and give a phone call to all the clients potentially affected to the same issue of that gear, in order to prevent others to experience the same issue, even before share that bad issues. Okay? So the crisis management is very, very important because, years ago, you had some issues, you send email, give phone call, no one knows that you had that problem. Now with social media and online channels, it's very easy for users to, let user know about a problem with a company. And another important thing is customer satisfaction. This is something that many companies are not understanding in the right weight, in the right impact. So it's very important to ask your clients if they're satisfied, and if the product is something that can be used not on a one time, but many times or for many years. It's very important to understand if they're still satisfied. First of all, because the moment a client buys something from you, but then the product works, but you don't use very frequently, what happened? You will tell other friends that the product is good, but don't buy this because you won't use after a while, Or, of course, worst scenario, customers are not satisfied. Why? What's the area that caused that unsatisfaction, so that the company can fine-tune that area? This is very important. For our clients, usually for the, let's say, one-off projects. Usually we ask for filling the customer satisfaction survey at the end of the project. And then we have a retrospect meeting with our team. Retrospect means in the agile methodology to double check what worked and what not during the project, and to get the feedback from the client. Then first customer satisfaction survey, retrospect meeting, and then we go back to the client for transparently understanding how we can, let's say, better our relationship or keep the same healthy for the future. With the recurring clients, so clients that have annual contracts, we do quarterly customer satisfaction meeting. We name these key account reviews. So our strategic account and project manager for the client every 3 months meet the clients to understand if they're getting results, what went wrong or good in the last quarter, what we need to do, and what kind of priorities you have for next quarter, in order for us to avoid that at the end of the year of the contract duration, we notice that the client is not happy and they don't want to sign for another year. So we need to revise before. When we started doing this, the churn of the annual contract goes down. So now it's very, very infrequently that a client doesn't confirm the contract with us. It's very, very difficult because of this, because we have the time and the transparency before the contract expires to fine tune and put our attention on the client needs. And last very important thing on the assistance and quality is the knowledge base. Knowledge base is something that is, let's say, stressful for companies to create, because it means putting together the know-how of the company. Know-how of the company is the sum of the know-how of any individual who works for the company. But the knowledge base is something that, first of all, put together the information that otherwise are in the mind of any individual. Put together the information means that the same information are available also for other employees that doesn't experience the same issue, the same information, or they experience the first time with a client. Then they can answer immediately because another colleague already experienced that issue and reply back in this way. Then you can do the same. Or next step is linking the knowledge base with a chatbot, and the AI will do everything 24/7, for example, for customer service, only if a knowledge base is there, is available, and of course is constantly updated. This is very, very important. Last thing is about data integration. So, as I mentioned before, the common problem for many organizations is that they have a lot of different softwares, database, with many information about the same user fragmented across different databases. And in the future, having a unique source of truth for your data is the key, because as I mentioned before, behavioral marketing will be different in the future. You need to use your own data. But if your data are spread across different databases, how you can group together and enrich your database for make it effective in the marketing campaigns? It's very difficult. So the key is to integrate those data into a unique system and to update and sync all of your crucial databases. But also, the moment you want to automate, for example, the order to pay, we were mentioned before, order to pay involves many softwares, internal and external. Payment gateway are not something that a company owns, right? They are implementing the gateway from, I don't know, Visa, MasterCard, American Express. Then the payment gateway gives back to you some information. Then you need to evaluate this information to proceed or stop the flow and so forth. That integration is very, very important. In order to avoid any issue, the first thing is to map your different sources of data and to understand your master data. Who is the master? Who will control all of the data? And which data you want to collect? Because those that are important for customer-facing roles, for digital marketing, for customer service. Okay. Even we need to integrate emails, calendars, ticketing solutions, help desk, website, CMS. So all the tools that usually are fragmented across many departments. And there you have a lot of information that is difficult to get if they are not in sync. Another important thing is to integrate, for example, the live chat or the telephony, because, for example, for the customer service, for many clients, we automatically feed the CRM with the outbound and inbound calls from the telephony central, creating some automations that in case the phone calls last more than 5 minutes, for example, it means the phone call was something important. So the sales rep should enter something, an outcome of the call. Or, for example, there are many cases like us, for example, that sell maintenance contracts. Maintenance contract means that every time you have some issues, you can write, send email, give phone calls without any additional cost. The issue is, for example, for a client who sells IT software for facility management. Facility management, it means that, with that software, you can ask for changing any item, any object, any light bulb, or everything in a building, right? They have a lot of requests for this. The issue is for them was to measure if the amount paid by a client was good enough in terms of resources invested for the assistance, right? But if you're not able to track this, how you can evaluate? So we integrated the telephony, the ticketing, the chat, the email, the calendars into a unique tech stack to centralize all this information under every maintenance contract so that the client can evaluate how many phone calls, minutes of calls, number of emails, number of meetings to the clients they did in the past at that amount. So they can divide by many metrics and understand that they need, for example, to hire some fees for some clients that were absorbing a lot of resources, but they were paying a small amount because the client has a small building, and then the tier of maintenance was depending on the building, but a lot of requests. And this is another example of growth agency approach. I'm not delivering to you just a technology. I want to deliver to you the technology and the processes that can help you grow your business. So data integration is very, very important, 360 degrees, and is something that at a specific enterprise level, some companies do as a core business, only data integration, system integration. Okay. Our tech stack is based on HubSpot. We already discussed about this, which is an all-in-one platform with 5 hubs. So sales hub, marketing hub, service hub, operations hub, and CMS hub for managing website. We build our consultancy around this tech stack. Now, what we are working in our agency in these months is to create our own tech stack on top of HubSpot, because HubSpot, through data integration, can be synced with many other softwares. Okay, for example, the telephony system is not managed directly from within HubSpot, but HubSpot can connect with the geolocation of your customers in order for you to understand on a map where your turnaround is more concentrated. Is something that is not out of the box from HubSpot. So we are selecting, depending on the 360 degrees approach on innovating the processes and procedures of a company, phone calls, in-person meetings, paperless and e-signature, and many other, which tools adopt in order to give a client a whole tech stack for transforming the way they digitize their company. And our certifications are the following. So we are a HubSpot Platinum agency, Google Partner agency, a Google Cloud partner. Supermetrics, it's I think a Czech company, but is the worldwide leading company for data pipeline and data integrations. So they gives you connectors across different tools to make it faster and reliable, the data integration. Shopify, I think you know, it's the leading platform for e-commerce website for small, medium enterprises. Zoom, we are partner of Zoom. And Jubilo, which is one of the 5 leading platforms for online event and trade shows, and Microsoft Advertising. So thank you for your attention. The methodology is something we already discussed about, so I don't want to annoy you. And I know that we are also ending up our time. So we already discussed about the method, from analysis, strategy, implementation, and customer success, and the workflow. And the solutions, I think we went through last week. So thank you for your patience and your attention, and over your passion in Italy and on the way you are experiencing our countries and our companies. I hope I gave you some useful information about how growth agency work and how they can work across many industries and many companies and organizations. And good luck for your future. We You have questions? Okay. Yeah, just a user has asked for Zoom that I don't know if you can read that. Sometimes it happened that he talked about something in the house, in the room, and then immediately they experience an ad, maybe on the smart TV or on the mobile phone. Yeah, this is another example of how privacy, it's, let's say, is having issues, right? Because you are talking and your mobile phone or your vocal assistant, Alexa or Google Mini, are always hearing about this. And then without your permission, or probably you gave the permission without knowing you were giving permissions, because when you accepted some, terms and conditions that have 40 pages to read, you scroll down, okay, you accept everything. But this is something that, for the privacy laws that are under revision or just issued, is not anymore allowed. So if you need to be informed and expressly give consent, not confirm 40 pages. I read 40 pages, okay, but then I want to confirm this and that expressly, not because just hitting something, you can do everything with my data. And this is an example of how in the future, hopefully, won't occur anymore, that you are talking about something and then after 30 minutes, you open Google, you tick on the search tab, and immediately already is filled with the inline skating you were discussing with your son at breakfast time, right? Yeah, this is scary, but this is why GDPR privacy laws are changing the regulations, and then how the marketing will change on the moving from third-party cookie to first-party cookie. So your data, not others. So yeah, this is about profilation and about how big vendors are abusing their position on the market and on the technology to get information, private information from the users, and sell this behavioral information to third parties. So this is something that, of course, will stop. And then on the other side, advertisers should change the way they promote their products. Okay, thank you, Mattia, for your question. Sorry for the delay on answering you back. So thank you again. Have a nice day. Thank you. Ciao.
Okay, so good morning, everybody. Morning. I'm Lorenzo Scalera. I'm a researcher at University of Udine. I'm a mechanical engineer, and I work in robotics. Okay, and today I will give you a presentation about collaborative robotics. Okay, so do you already know what is collaborative robotics? Maybe a little bit. What is a collaborative robot? Okay, in a shared environment. Okay. So what is the outline of the presentation? I will give you a brief introduction about robotics in general, mainly industrial robotics, and then we will go to collaborative robotics. So to highlight the differences between traditional industrial robots and collaborative robots. Okay, then I will give you an introduction about the regulations and standards for safety, because safety is really important in collaborative robotics, because we have an interaction with a human, and we have to avoid unwanted contacts between the robot and the human, and we don't want the human to be damaged by the robot. Okay, we will take a look at the robots in the market, and also I will show you some research activities that we do at the University of Udine about collaborative robotics. So let's talk about robotics. What is robotics? Robotics is the study of machines that can replace a human in the execution of a task, both in terms of physical activity, but also decision making. So not only physical activity, but also decision making. We can define an automaton as a mechanical machine with the task of replacing a human. The term robot came from the Czech word robota, which means executive work, and this term was coined in 1921. So it's more than 1 century that it's more than 1 century that we talk about robots, and we use the term robot. Okay. I would like to show you a video about the first industrial robot, which is the Unimate. Okay, this robot was invented in 1954. Okay, and it was used for handling automotive parts. In the first automotive lines to build cars. Okay, with this kind of robot, more than 120 cars per hour were assembled. And in the video you can see this first prototype of this robot doing some basic tasks. So the idea to build a machine like this is to help the human. So here you can also see an example of collaborative operation. So the collaboration between the robot and Joseph Engelberger, who was the inventor of the robot. We can define also what is a robotic system. So a robotic system is a device from the mechanical, electrical, and IT points of view. And this device can be has to be capable of performing a specific task autonomously. What are the elements of a robotic system? The main elements of a robotic system are the workspace, the mechanical structure, the sensors, the elaboration unit, and the actuators. We can do a simple example of a robotic system. For example, a vacuum cleaner robot. Is it a robotic system? So yes, because we have a specific goal. Okay, we have a working environment, which is the room in which the robot works. We have a mechanical structure. We have also a processing unit. The processing unit is the computer or the electronic board on board of the robot that process the signals coming from the sensors of the robot and provides signals to the actuators of the robot. So for example, the sensors on board the robot can provide information about an obstacle, for example, and then the the computer on board steers the robot to avoid the obstacle. Okay. So robotics can be defined as a science that studies the intelligent connection between perception and action. Perception is the perception of the informations from the sensors, and the action is the action that we perform with the actuators. So we have a mechanical system, a sensory system, and a control system. The mechanical system deals with locomotion and manipulation. So if we have a mobile robot, the locomotion is the motion of the robot in the space. The manipulation is the handling of the objects or some manufacturing tasks that we can do with some products. Then we have a sensory system, and here we can define the two types of sensors: proprioceptive sensors and exteroceptive sensors. What are these two kinds of sensors? The first acquire information about the internal state of the robot, okay? And the exteroceptive acquire information on the external state. And then we have the control system. What are examples of proprioceptive sensors? So if we have to measure the internal state of the robot, for example, we can measure the position of the motors, the velocity of the robot, or also the temperature of the motors. The exteroceptive sensors measures the surroundings of the robot, so the environment. For example, a camera to have visual information about the environment, or humidity sensors, or laser sensors to have a reconstruction of the 3D environment. These are some examples of sensors that we can use on board the robot. So, for example, position, velocity, acceleration sensors, or force sensors, proximity sensor, distance sensors, and vision sensors, camera systems. Now, I would like to show you the components of an industrial robot. So this can be one classical, traditional industrial robot. We have a mechanical structure, and then we have a control system. The manipulator, so our mechanical arm, can be defined as a sequence of rigid bodies, links, and joints. As in our arm, we have rigid links and the joints that allow us the motion. The joints can be revolute joints if they provide a rotational motion, or prismatic joints. Prismatic joints is a joint that allow a linear motion. Okay, for example, a linear displacement. So these are two links. For example, these are the joints of the robot. Then we have a base. The base is where the robot is fixed to the ground, and the end effector. The end effector is the place where we connect the tool of the robot. The end effector is the place that allow the robot to perform the operations on the operations that we want to perform. Okay, so support structure, actuators, and sensors. By talking about the support structure, we can also talk about the wheels. So we have the superstructure of the robot, but at the end of the robot, we also have a wheels, as in our hand. And the wheels gives dexterity to the robot. Dexterity means the capacity of orientation, so how to orient the tool of the robot in the space. With the wrist, the robot can reach the same point with multiple orientation. As when I write, okay, I can reach the same point, but with different orientations to perform the task better. Then also the control system is really important. So when we talk about the robot, we don't have to think only about the mechanical structure, but also the control system, because without control system, we cannot move the robot. We cannot give a trajectory to the robot. What is a trajectory? A trajectory is the sequence of positions, but also velocities and accelerations that the robot has to perform at each instant of time. Because we can make a difference between the path and the trajectory. The path is simply the geometrical path. For example, I have a welding robot. I have to weld along a square path, okay? But how do I travel on that path? I can go very fast, or I can go very slow. So the trajectory not only considers the path, but also the velocity and the accelerations that the robot should have at each instant of time. A brief introduction about the classifications of manipulators. So mainly we have two main types of robots. Robots with open kinematic chain. You can see this is a robot with an open kinematic chain. It means that there is only one sequence of links and joints from the base, from where the robot is fixed to the ground, to the end effector. But we also have robots with parallel kinematics, and these kind of robots are called robots with closed kinematic chain. It means that there is more than one sequence of links that goes from the base to the end effector. In this case, this robot is a parallel robot. The base is on the top because the robot is fixed from the top, and it works like a spider, okay, to perform very fast operations. Okay, this is just the classification of the joints that I already told you: revolute joints and prismatic joints. And very, very quick, some examples of manipulators to give you an overview on the main kind of manipulators that we can find on the market. For example, the SCARA manipulator is this kind of robot. It is used for very fast pick and place operations. And here there is also a video of one SCARA robot to show you how the robot works. So this is the robot and the control box. This kind of robot works with small objects, so it performs very fast pick and place operations. For example, in the factories where we need to build an electronic board, these robots can help in mounting electronic components and so on. So the motion in the horizontal plane is very fast, and usually the robot also works with a camera to identify the piece, the object on the conveyor belt. Okay, another example of robot is the articulated manipulator, the classical manipulator. These are some examples of articulated manipulators. And at the end of the manipulator, we have the worst. The worst, we have already said that is the device that gives dexterity to the robot, so the capacity to achieve a different orientation in the space. We can have robots with spherical worst or non-spherical worst. I don't want to go much in detail in the technical details, but if the axis of the three links, the three joints intersects in one point, we have a spherical worst. Otherwise, the worst is not spherical, but it's just a detail. Then we have parallel robots. We can have parallel robots for many different applications. For example, Stewart platform is a parallel robot, and it is used for the flight simulators. For example, this is a flight simulator, so the pilots, instead of training on a real airplane, they can train on this simulator, and the robot can move the cabin in the on the three axis and three rotations to simulate the flight of the robot. Or another application is the haptic interface. For example, the haptic interface is used in the robotics for surgery. So the surgeon moves these devices, which are actually small parallel robots, and the real robot replicate the motion on the patient. Okay, this is another application of parallel robots. Parallel robots in general are very fast, so they have a light structure with respect to serial robots. They have very high speed and high acceleration, but the payload is lower. And they are used for handling small objects, for example, also in the food industry. This is an example of the application of a parallel robot. So this was a chocolate factory. And then they decided to start using a parallel robot to put chocolate in the boxes for safety reasons. So this is the chocolate factory, and here you can see the parallel robot. Maybe okay, so this is the parallel robot. You can see that the movements are very fast. Other examples of robots that maybe you do not know are cable-driven parallel robots. So we can have robots not only with rigid links, but also with flexible links. One example is given by parallel robots where the links are not rigid but are flexible, are cables. Some examples are the Skycam. So the Skycam is a cable robot that is used to make the videos during the football or tennis games. And by modifying the length of the cable, we can move the robot, the end effector of the robot, so the camera in the space, in the 3D space. Another example is the cable robot simulator. This is a very huge simulator for flight or other thing. You can sit here on this platform and wear a virtual reality helmet, and the robot can move in the 3D space very fast. Other examples of parallel robots with cables are this radio telescope. So this is a very huge telescope, and the antenna of the telescope is mounted on these cables, and by moving the cables, we can modify the orientation of the receiver of the telescope. Now this telescope here in Puerto Rico was destroyed a few months ago, but now they are building a bigger one in China with a diameter of 500 meters. So 500-meter radio telescope where the antenna is supported by cables. Or we have cable robots for rehabilitation. So cable robot can help the patient to perform a long rehabilitation also without the need of medical person. Other robots are mobile robots. Mobile robots are robots that can move with wheels or with legs in both indoor and outdoor environments. For indoor applications, you know for sure the vacuum cleaner robots, or also the Amazon robots that move the packages in the factory. Or outdoor applications, for example, robots for planetary exploration, robots for agriculture, or for also underwater exploration. Robots for agriculture are very, very popular in this moment. So they are starting to be used very much for monitoring and also mapping the agricultural fields. For example, at University of Udine, we are trying to develop a robot for monitoring the vineyards. So the robot can autonomously move in the vineyard and build a 3D map of the grape vines. So we can measure the volume and the dimensions of the plants, and also decide if there is a water stress in the plants, or if the plants are healthy or no. Then we have wheeled mobile robots, means that we have a mobile-based and a manipulator on top, but we can also have mobile robots on legs, such as the robots by Boston Dynamics that you maybe have seen in some videos, spinning and running. What are typical applications of an industrial robot? Transportation, manufacture, and measure. So we have many applications: handling, pick and place, loading, unloading machines, palletizing. Many robots are used in the packaging industry just to package the objects. Manufacturing tasks such as welding, spray painting, and so on, or measure. quality control, for example, dimensional tests, identifications of error or defects. This is an example of welding robot in the automotive industry. These robots are used for welding the chassis of the cars. Maybe you have already seen videos of welding robots, no? Not much. So you can see these applications of robots are completely automated and there is no human intervention. So the robot is separated by a cage where the human cannot enter during the robot operation. Another application is the spray painting. Spray painting is another example of application of industrial robots where the human cannot enter during the operation because there is a toxic environment due to the spray paint. This is a video of spray painting robot for painting the chassis of the cars. This is done by a company which is close to Udine, close to here. I would like to. Okay. Spray painting is very challenging because the speed of the robot has to be controlled very, very well because we cannot go too fast because otherwise we will have too less paint, but we cannot go too slow because otherwise the thick of the paint will be too high. So should have a constant speed during the operation and also keep the distance between the robot and the surface constant and keep the spray paint as perpendicular as possible to the surface. This is not really easy when we have a complex surface or a curved surface as in the car chassis. Okay, so this was just to give you some examples about industrial applications of robots, but now we will have to talk about collaborative robots. So we move from industrial, so traditional robots that are, for example, welding robots, to collaborative robots. In these two images, what is the main difference in your opinion? Please. There is a human. There is a human. Oh. There is a collaboration between a human and robot. So the robots are not closed in a cage. There are no barriers, okay? But there is a collaboration between human and robot that share the same workspace. What does collaborative robotics mean? So being collaborative means to work with someone to create or produce something. And collaborative robots are robots that bring together the potential of human and robot capabilities to complete a task together. So to complete a task together using both capabilities of the human for the most how do you say decision tasks, and using the capabilities of the robot for the more repetitive tasks. Okay, so human and robot collaborate together in the smart factory, and here we can see also the four four stages of the Industrial Revolution. So we had the fourth Industrial Revolution in the late 18th century. Then we had the second Industrial Revolution in the early of the 20th century. Then the third was with the introduction of electronics and computers. Then now we have the Industry 4.0, so the fourth Industrial Revolution with the cyber physical systems, and collaborative robotics is one of the enabling technologies of the Industry 4.0, together with other tools that you might know, such as virtual simulation, virtual reality, IoT process and production, and so on. So now let's take a look at the main features of collaborative robots. So collaborative robots are slower and less powerful than traditional robots because they should usually do tasks that were previously done by a human. So collaborative robots has to work at the same level of strength and speed as human, are safe, light, transportable, and flexible. They are easy to program. Usually, collaborative robots can be programmed with a tablet, okay, with a tablet which is called Teach Pendant, where we can teach the points where the robot can go. We can also take the robot with our hand, disable the brakes, and teach one point of the robot, then another point, and then the robot repeats the motion by itself. With collaborative robots, the production layout is simplified because there are no barriers. So we can take the robot and move it in another position very easily because also the robot is light. Simplify the installation of the robot and improve working condition of human operators. Other features are safety features. So usually collaborative robots have safety systems for speed limitation, force limitation, and power limitation. Also, they are designed with round joints, plastic covers to ensure that in case of contact between human and robot, there is a softer, let's say, impact. And they are as ergonomic as possible. Some enabling technologies for collaboration. So we not only have to consider the manipulator, so usually we have lightweight robots, but also we have to consider the gripping. So if the robot has a gripper, also the gripper has to be saved. It doesn't have to cause injuries to the human, and never lose the grasped object. Okay. Then we have safety-rated functions and sensors. So the robot usually has many safety sensors, safe control schemes, and redundant architectures. And if the robot is mounted on a mobile manipulator, we also have to consider safety for the mobile manipulator. It is important that in our collaborative robotics, application, we don't have to consider only the manipulator and the gripper, but we have to consider all the application. So we have to consider the robot, the gripper, but also the grasp, which has to be safe, the manipulated objects, the environment, the interaction between human and robot. Because if we have a collaborative robot and we mount a knife on the robot is not collaborative anymore. So in our application, we have to consider all the environment, all the details that can cause an injury to the human. What are common applications for collaborative robots? Pick and place operation. The most common is pick and place, just picking and place, but also packaging, manufacturing, assembly. Assembly is an operation very, very common for a collaborative robot. So also the collaborative assembly. So if I have to assemble a very complex part, the robot can help the human in the assembly. So part of the assembly is done by the human, and another part is done by the robot. Here there are some. Here there is a table of for a classification of the features of traditional industrial robots and collaborative robots. So traditional industrial robots are usually blind, are not aware of the surrounding environment, are more dangerous. This is because they are closed in a safe workspace. They have high precision and high repeatability. They usually are programmed for a specific task. They require components and integration. They require a very long software development, and generally they are expensive. On the other side, collaborative robots can perceive the environment and the people, because collaborative robots are usually supported by camera systems or other sensors that can make the robot perceive the environment and the human. They are safe, but they have limited precision and repeatability, because generally they are less stiff. So if the robot has to dissipate energy in case of contact, the robot is less stiff, so it has less precision and less repeatability. But this is not a problem, because usually the tasks that are used for are not tasks that require high precision and high repeatability. We already said that collaborative robots are easy to use and to be programmed, also thanks to the tablets that we can program with the tablet, and are generally low cost with respect to the same with respect to traditional industrial robots of the same payload, for example. Now we take a look at the types of interaction with industrial robots. So from the perspective of the human, we have 4 types of interaction. The first is the separation. Separation is the interaction that we have in traditional robots. So there is no interaction. Okay, so no interaction between human and robot. Then we have the coexistence between robot and human. Coexistence, what does it mean? It means that human and robot can work together in the same time, but in different spaces. So they work together, but in different spaces. So they don't share the workspace. The cooperation between robot and human is that human and robot work together in the same space, but in different times. For example, in the collaborative assembly, the robot can perform a task when the human is not in the workspace. Then the robot stops and the human performs another task. That's the cooperation. But the collaboration is the fourth type of interaction, and the collaboration is the interaction, the more completed interaction. Okay, so when human and robot perform a task in the same space and in the same time. So usually when we talk about collaborative robotics, we refer to the word collaboration, but usually in collaborative robotics, the majority of the applications are coexistence application or cooperation applications. And now we take a look more in detail of these four in types of interaction. So the coexistence. In the coexistence, we said that we have robot and human working in the different spaces at the same time. Is the situation in which human operators and machine operate simultaneously but in adjacent work areas. An example is the loading station with a rotating table. So the operation, the concurrent operation is possible thanks, for example, to a safety barrier. The cooperation, same space, different times. So human and robots operate in the same working area, but at different times. For example, a robotic assembly station. In this case, the distance between human and a robot has to be monitored, for example. So if the distance between human and robot is too small, so if the human is too close to the robot should stop or should decrease the speed in order to avoid a potential collision. Finally, we have the collaboration. Collaboration when robot and human work in the same space in the same time. So this is the full interaction between human and robot. In the collaboration, human and robot share the workspace at the same time. And in this case, the safety that we apply to the coexistence and to the cooperation is not enough. We have to develop. We have to consider we have to consider more things for the safety. And in this case, we have to consider also the position and the speed of the robot in real time. So since safety is very, very important, now we take a look at the regulations and standards for safety, in particular between human and robot. So since the 40s, in the last century, Isaac Asimov brought the three fundamental laws of robotics. Maybe do you know the three fundamental laws of robotics? Any of you? No? So Isaac Asimov is a science fiction writer, and he wrote I, Robot. It's a very famous book about robotics. And these three laws are: a robot cannot hurt a human being or allow, by remaining inactive, a human being in danger. Second law, a robot must obey orders given by human beings unless these orders conflict with the first law. Third, a robot must protect its existence unless such protection conflicts with the first or second law. So these are the three laws of robotics taken from this science fiction book, but these laws now are, let's say, integrated in real standards for safety and the technical specification. In particular, considering industrial robots, it's really important to consider the ISO 10218 robots and robotic devices safety requirements for industrial robots, and the technical specification ISO TS 15066 robots and robotic devices collaborative robots. So these are the two standards for safety that you might consider if you work in collaborative robotics. And now we take a look at some definitions that we have for collaborative robotics. For example, the ISO 10218 defines human-robot collaboration as the state in which a purposely designed robot works in direct cooperation with a human in a defined workspace. So what does it mean? It means that the robot is designed for working together with the human. So there are safety requirements to be considered in the design of the robot. And workspace means collaborative workspace. So the space where robot and human can work together. Okay, so not everywhere, but only in a well-defined area. Now we take a look at the 4 basic principles of collaborative robotics. So these are 4 scenarios in which a collaborative robotics application can be implemented. So this is very important. So these are the 4 main, let's say, scenarios of collaborative robotics. So the first scenario is safety rated monitor stop, which is this one. What does it mean? It means that there is an area around the robot, and when an operator enters in this area, the robot has to stop immediately. Safety rated monitor stop. So I monitor an area, and when the human enters that area, the robot stops. So there are no barriers, but there is an area that is monitored, for example, by a laser sensor or by a camera. So in this case, there is no possibility of contact between human and robot. In the second scenario, hand guiding. Hand guiding, the movements of the robot are controlled by the operator thanks to suitable devices. So in the hand guiding, what can I do? I can disable the brakes of the robot, grasp the robot, and move it, for example, to learn a point. So I move the robot with my hand like this. I bring the robot to one point, then I record that point, then I disable the brakes again, I move the robot in another point, I record that point, and then the robot can repeat. So in the hand guiding, there can be a contact between human and robot. Then we have the speed and separation monitoring. Speed and separation monitoring means that I have to monitor the speed of the robot and the separation between the robot and the human. If the robot gets too close to the robot has to slow down. And if the human gets too close, the robot has to stop. Okay, for example, I can define, for example, 3 areas. The green one, where the robot works at full speed, the yellow one, where the robot works at half speed, and the red one, where the robot has to stop. So also in this case, the contact between operator and robot is prevented. So I cannot have contact between human and robot in motion. only between human and robot stopped, okay? Then in the fourth case, which is the power and force limiting, the forces released by the contact between human and robot are rendered harmless. So I can have a contact between human and robot, but I'm sure that that contact is not dangerous for the human. Okay, so there can be a contact, but I have to make sure that in case of contact, the human doesn't hurt. So in the safety rated monitor stop and speed and separation monitoring, so these two cases, no contacts between human and robots. Contacts are only possible in hand guiding and power and force limiting. So this is one of the most important slides of the presentation, okay? Okay, here we can go a little bit more in detail, but I just repeat what I've already said. So first, in the first scenario, safety rated monitor stop, there is a monitored area and the robot stop when the human enters that area and restarts as soon as the human goes out of that area. In the hand guiding, the robot can be guided manually and controlled with an appropriate reduced speed. The operator can teach the robot positions by moving the robot without the need of an extra interface. Speed and separation monitoring, both speed and motion of the robot are supervised, and also the distance between human and robot has to be supervised. Nowadays, there are many devices such as deep camera, depth camera. I don't know if you have heard about depth camera. Depth camera are cameras that can measure also the distance. And with artificial intelligence algorithms, I can build the skeleton of the human. So I can use a skeleton tracking algorithm to track the position of the human in real time, and then calculate the distance between the human and the robot in real time. So when the distance between the human and the robot is too close, I can stop the robot, reduce the speed of the robot, change the trajectory of the robot, change the path of the robot, and so on, in order to make the robot safe. Okay, this is also the same example of speed and separation monitoring. So a green area where the robot, for example, work at the normal speed, yellow area where the robot gradually reduces the speed, and the red area where the robot has to be stopped. Finally, the power and force limiting. In the power and force limiting, the risk is mitigated by limiting the mechanical impact between human and robot. In this case, we have to consider all the components of the environment: robot, tool, workpiece, task, velocity of the robot, and so on. We can have two different kinds of contacts between human and robot: transient contacts and quasi-static contacts. Now I can show you this slide. In the transient contact is when the robot, for example, hit my arm and then moves away. This is a transient contact. So in the transient contact, the control system of the robot doesn't have time to stop the robot. But we can have quasi-static contacts. Quasi-static contacts are when, for example, the hand of the operator is scratched between the robot and the table. or one finger of the operator is scratched. In that case, the control system has to stop the robot. So the technical specification also reports levels of maximum force and maximum pressure that we can perceive in the different parts of our body. So we have to consider that a transient contact is possible if the force and pressure on, for example, our hand or our arm is below the thresholds defined by the technical specification. Okay. Do you have any question? No? Okay. Sensors for collaborative robots. So to ensure safety without physical barriers, there are many sensors that can be used. For example, safety curtains, laser systems, or non-contact safety switches, safety laser scanner, cameras, also force and torque sensors. And other sensors are, yes, vision systems already mentioned, sensors for recognizing voice commands, or contact sensors. So in collaborative robotics, it's very important to integrate the robot with the sensor needed for our application. Okay, in order to make the full application safe for the human. Now I would like to show you some data about the annual installation of industrial robots. So this is the trend of annual installation of industrial robot worldwide. So, for example, in 2021, more than 500,000 robots were installed worldwide. This is the operational stock of industrial robots. And the annual installation of industrial robots by industry. So you can see that electrical and electronic industry is one of the industries that requires more robots for the assembly of components. Then we have automotive, but also metal and machinery, plastic and chemical products, food, and others. By application, handling, welding, assembling, cleaning, and the collaborative and traditional industrial robots. So in blue, you can see the traditional industrial robots, and in red, the collaborative robots. So from 2020 to 2021, the trend is plus 50% of collaborative robots. So there is a trend in increase of using collaborative robots. And the annual installation of industrial robots in the last year. So now 2023, 614,000 units of industrial robots. And a slide about collaborative robot market by payload capacity. So you can see collaborative robots can handle up to 5 kilos, up to 10, or above 10 kilos. So most of collaborative robots handle maximum 10 kilos because they are suited for handling small objects. Some examples of leading manufacturers of collaborative robots. So you can learn some names of companies. Do you know any company about collaborative robots? No? The market leader is Universal Robots. Universal Robots is a company from Denmark. The company is in Odense in Denmark, and they produce these robots, these light blue and gray robots that can have 3, 5, and 10 kilos of payload. So these are the models UR3, UR5, and UR10. Company was founded in 2005, and they have more than 10,000 robots installed all over the world. Another big company of collaborative robot is Fanuc, that produces these robots in green. Then we have also Techman, Rethink Robotics. Rethink Robotics was a very big company for collaborative robot, but closes in 2018, and they used to produce these two robots, Baxter and Sawyer, that were equipped with a display, and on the display you can see the robots in motion. So collaboration between human and robot becomes more intense. Then we have Aubo Robotics, FNP Robotics. Just to give you some examples, these robots are covered by a soft skin. So if in case of contact, there is a soft contact between human and robot. Then KUKA. KUKA is a very big company for robotics, one of the bigger companies on the world. They produce these collaborative robots with 7 axes, means they have 7 motors, 7 electrical motors. Or ABB. ABB is another very important company for robotics. This robot is called Yumi. Yumi means you and me, and the robot is built with 2 arms, like in a human, and it's is used for assembling or moving very small objects. Other interesting robots are the Franca Amica robot. Franca Amica robot are also called Panda robot because they have these gray and white covers on the joints as in the Panda. Another robot is the Comau Aura. Comau is a company from Italy, robotic company from Italy. Comau used to produce the robot that are used in the Fiat production lines. So the robots that are used to assemble the cars for the Fiat company. This is a very big industrial collaborative robot. So it is collaborative because it is covered by contact skin. So when you touch the robot stops. So even if it's very big and can have a payload of 170 kilos, the robot is safe, however. And then we have some examples of mobile robots. Mobile robots, for example, these KUKA mobile robots, the mobile base with the arm, some mobile robots of ClearPath Robotics. This is a company very famous for mobile robots. They also produce underwater robots, and a very good company. MIR Mobile Industrial Robots is another company for mobile robots used in the industries, for example, to moving pallets or packages in the industry, Omron, another big company, and we also have humanoid collaborative robots. These, of course, are produced in only few pieces, but for example, these are some examples. The RoboNow 2 that is used by the NASA, the Next Age robots, or the robots Justin and Toro by the DLR. DLR is the German Aerospace Center in Munich. You can see these robots that are trying to learn many different applications, such as cleaning solar panels or something like that, because they want to send these robots to Mars maybe one day. And finally, some research activities at University of Udine. So you can see in Udine we have some of these Franca e Mica robots, and this is one of my PhD students. And in Udine we have developed an approach for collision avoidance in collaborative robotics. And the idea of our approach is to consider the human and the robot enclosed in capsules, like in bubbles, okay? And consider these bubbles not static but dynamic. So we can modify the size of the safety zones around the robot with respect to the speed of the robot. So when the robot goes very fast, we can enlarge the safety zone, but when the robot is very slow, we can make the safety zone smaller. And only when there is a potential collision between human and robot, we stop the robot. This is an example of how the algorithm work. So you can stop the robot without touching it. How does it work? There is a camera that tracks the position of the human with a skeleton tracking algorithm. And we calculate the distance between the human and the robot in real time. And considering these like bubbles growing and during time, if the distance between human and robot is less than the radius of the bubble, we stop the robot. But then the robot can restart as soon as the safety condition is satisfied. So we don't use the brakes of the robot, so the robot is not stopped forever, just stopped with a trajectory. So we say the robot to stay at 0 velocity and 0 speed, and then restart as soon as the safety condition is satisfied. In this slide, I can show you some simulation results. So we compared 3 different approaches for the safeties. In this approach number 3, we have implemented the safety as in the technical specification. So as in the norm, in the regulation. So the safety zone of the robot is very big, and when the human enters, the robot stops. In the second approach, these bubbles can grow and become smaller, but just with discrete values. So they are not smooth, but they only have discrete values. And in the first approach, the size of the bubbles is optimized. So we use the minimal size possible. I can show you. And you can see that the size of the bubbles around the robot here is smaller than in the other 2 cases. And in this way, the robot can complete Oh, there is a problem with the video. It completes the operation faster. So the first is completed in 13 seconds, the second is completed in 18 seconds, and with the third approach, the operation is completed at 28 seconds. So same operation, but only different safety strategy. Because the idea is to make the robot safe, but at the same time, the collaboration between human and robot has to be fluent, because we don't want the robot to stop too much, because otherwise it's not productive. We have to, we want to have a very fast cycle time to complete more operations in the same time, to make the robot productive, and have a fluent operation and a fluent collaboration between human and robot, considering safety at the same time. So this is the, then so first of all, we did the numerical simulations, and then we validate the simulations on the real robot. So this is the real robot. We have the camera and the calibration tip, some markers, and so on. And this is a slide where you can see how the distance between the human and the robot is computed. So if we have the skeleton of the human, so this one in yellow is, you cannot see the arrow. Okay, so in the figure you can see the skeleton as it is recorded by the camera, and each segment of the skeleton of the human is measured with respect to each segment of the robot. So we compute the distance between all combinations of segment, and we take the minimum distance, and then we can apply our algorithm. We did some experimental tests, so we have 27 people that were asked to work along this path or along this other path while the robot was performing an operation. So by comparing different safety approaches, we would like to test which is the best one. This is an example of a test. So you can see that the robot stops when the human is closed, and then restarts. And then some experimental tests where we compare the same three approaches that we have seen in the previous slide. So in this approach, we use static capsules. In this approach, we use dynamic safety zones, but with only discrete sizes. And in this approach, we use the online optimization for minimizing the size of the safety zone. So here, the task is completed in 35 seconds. In the second approach, it's completed with 42 seconds, and with the static capsules, which is the most conservative approach, it takes longer. And Federico had to walk a lot. I don't remember. Few days. No, 81 seconds. Okay, so to conclude, I would like to show you also some other applications. So not only industrial applications, but we can use collaborative robots also for other applications such as artistic operations. We have developed some algorithms for image processing and painting with collaborative robots. You can see in the video on the bottom right, robot painting with watercolor, with the brush painting, or another example with palette knife painting. So the robot picks the color with a palette and then place the color on the canvas. And here there is an image processing algorithm that, starting from a digital image, it elaborates the image, and then all the paths are sent to the robot to draw the artwork, to paint the artwork. It's not easy because you have to consider not only the position but also the orientation of the palette knife to place the color, or of the brush to place the color on the canvas. Okay, this is a video of some watercolor robotic painting, just to show you what we can do with collaborative robots. And this is the final artwork. This is a speed up video of another robotic painting. So you can see that the robot paints by layers. So there are many layers of color, also of different colors, that can mix on the paper together. This is a famous the painting is so the man in the painting is a famous theater actor in Italy. It's called Paolini. And a goat. Yes, we try to paint everything. So in all these examples, we started from a digital image that was elaborated by software, and then the robot paints that image. But we can also have a higher level of interaction between human and robot. For example, painting with eyes. This is a video where we showed our robot for painting with eyes. What does it mean? It means that we can use a device. It's called eye tracker. The eye tracker is a device that we can place under the screen, and with our eyes we can look at the screen, and moving the gaze point we can track an image, and then the robot reproduces the paint. And so this was shown at an exhibition in Trieste before the COVID, and then the robot paints the lines or the images only drawn with the eyes. Yes, this was painted by a child. It was fun. Okay, thank you for your attention. Do you have any questions? Thank you.
Hello, everybody. My name is Egon Modica. I'm coming from University of Madrid, one of the partners. And today I would like to present you a little bit about quantum computing. So, how are the quantum computers made? What's the idea behind? We'll try to compare them with the normal classical computers. And then at the end, we'll make a simple program in a quantum computer. Because IBM and many other companies, they are offering service, they're offering quantum computing to everybody. So I'll show you how you can log in to the web page and then write a program. But you will see it's for fun. It's not to do some real calculations. Okay, since I expect that most of you are not from natural sciences like physics, mathematics, computer engineering, I also don't expect that you will ask me some difficult questions. So whatever you will ask, it would be welcome because it will keep me motivated to tell you more. Okay? And also now I will start this lecture with an experiment. I would like to invite you closer, then later we'll start. Because I'd like to explain you what is the quantum nature that we are using. Okay. Anytime you can stop me and you can ask me. Now I'll try to see. Okay, so this is the outline. First, this experiment, then another experiment. Then I'll compare to classical computers. Then we'll introduce this quantum information. And then we will try to model an experiment with quantum computers. So let's start with this experiment. This famous experiment is Michelson-Morley experiment. It was done in 1887 by these two guys. And it's a very special experiment because as it's so simple, it can show us what the quantum nature means, how we can meet the quantum nature. So what we have a red laser here, the red laser, which is shining through this lens to make it wider. And then it comes into this part. That part is nothing else than a mirror. So one mirror is here. And one mirror is, do you know this experiment? No? Then we put a piece of semi-transparent glass. Because we wish that part of photons goes to one mirror and the other part goes to the other mirror. And then they will reflect from the mirror and they will combine together. So we put a screen, this is our screen. So if we shine with the red laser to this semi-transparent glass, this mirror, the light will reflect back to this glass. And here from this glass, it will reflect to the screen. This is what you see here. The light is being reflected. So this is the red one. Can we see this red one? So if we put a mirror on the other side, we shine to the glass, then it reflects to the other mirror and back to the screen. No? So do you have a piece of paper? see the light is reflected from the window, mirror, then it goes back to the screen. If I block it here, front of mirror, then it doesn't. But then the funny things happen. If I put that the light goes through both pathways, look at the screen there. Something strange happens. Oh. And here I have a lever. And if I adjust the position of this lever, I can play with the But look, if I block one of the mirrors, the light is normal. If I release, you can come here now and try by yourself. Please. So if you block one of the lights, you see it's uniform like here, no? It's just a normal reflection. If you block the other one, it's again normal. If you leave both of them, then it comes to the strange effect. Right? See, now there are both of them. That's the mirror. Yeah, this is the transparent. If you block both of them, there is no light. Or you block the glass. So this glass, you need to leave it free. So this phenomena here makes such a kind of red shape because the appearance of light. But it means that the photon carrying the light goes to this glass, then it continues in this way or in this way. Then it comes here, and there is no left. Some kind of nature. This is the quantum nature of photons. So everything that is in nature is quantum. But these effects came into appearance only in certain conditions. And this is one kind of conditions that we set up here to observe such effects. So this interference means that there is no light. No light is coming there. Although if we block one of the mirrors, see that the light is coming everywhere. But then once the light is not coming, we can leave both mirrors. If each of the mirrors brings the light here, but both of them, they don't bring it. No? And if we move the mirror, we can decide whether the light will go there or not. No? The second experiment will be the one, again with photons. We will shine to a slit which has two gaps inside. And then what will happen after? We will see some strange shape. We know the mathematics to describe this kind of effect. And this is the movie, the animation of photons, which will come to these gaps, slits, and you will see how these photons will propagate after. This mathematics is counting the nature of photons, that they are quantum particles. But let me show you. How complex is this effect? Tina, help. Maybe we will have to show it here. Oh, I see. Okay.
We can show it from here.
Just on the cross. But before it was working.
If there's the video file. No, non c'è il video.
No trouble. I will show it. And then we continue with that. Okay, let's see now. So you see the photons are coming to the gaps. Some of them like that, and the others continue. But they do not continue uniformly, but they continue like so the shape of the light that you get here is some kind of okay. Like here. Understand what kind of pattern you get.
Sorry, my fault.
Get the pattern of different spectral lengths. It's the light propagates like a wave when it comes to these two gaps. We know that it propagates like that it's coming out of these two gaps. And these two gaps are different sources of light. And then we see the light intensity making such nice pattern. But let's do an experiment. Let's use very low light intensity. Very low light intensity. And we take a photographic film which record every photon which comes right. And we go to the next one. Yes. So we just pass very few photons to these two slits. And we will see something like this. This is a real experiment. They develop the field. Then when they do more photons, they already start to see the spectral lines. So you already have some idea what's going to happen. Then visit, get already some well, solve futures and then with a lot of focus, like 10 to 10, have already nice interference pattern, as it is known, which was studied for many years. Scientists were fighting how to explain this behavior, but this is another story. So this is a computer simulation, which it means each photon goes through the slit and it ends up somewhere. Oh, you see. But how the photon knows where to go? It has some brainstorm, some right to decide on what. So this is the interesting part of quantum physics, quantum nature. So where will each of these photons go? This slit and end up here. So this slit and up here. So this slit and up here. We don't know. Yet today we don't know this. So it will take this way or it will take this way. We don't know. We don't know since we measure this photon. But I will come to this later. So let's think, let's refresh what we know. We know mathematics. We know what kind of shape this will be. We know exact function of it because we know where the bunch of photons will go. So if we take millions of photons, we know where they will go on average. So this is the average place where the photons will go. But if you take an individual photon, quantum photon, we have no clue. We don't know where the photons will go. Photons will go somewhere. On average, they will go like this. But each individual, and how this individual knows that there are already hundreds of them, so he should not go there, otherwise the average will change. So this is the problems that we still don't know. But, and this is the fact that these quantum particles, they obey quantum nature. And we can take advantage of this. We can take advantage of this and use it to make some technology which will help us. For example, can you think about, you have something which is random. What kind of machine you will make? So you have something behaving very random. Take advantage of this. You will make some machine. So what you will do? Energy production. So we can make random machine out of this. Let's make it. Huh? So we take a single photon source, which will emit single photons. We make two holes in a plate, and then we put a single photon detector, whatever it is. Huh? This is some piece like this, very expensive, but it detects a single. And then we emit photon, and if we detect it here, we get number one. If we detect here, we get number two. And we have a random machine. And this is random the quantum computer, taking in quantum effects. And we can make more holes, no? and we can make a generator of quantum dice. This will be the very, very expensive quantum dice. No? But the idea behind this is the quantum computer. Yeah. Got some ideas how to do it. No, but just tell you. Okay, what else? Yeah, now let's do some theory. Quantum computer has different parts, and these parts are named. This is the source. This, the most important part, is called gate. This is doing the calculation or decision. And then this part is the measure. Because at the end, you need to measure to see whether came to this or this. So here we launch from our world, quantum world, then we bring back to our world. Our world means the world which our brains can accept. Yeah? Any questions about here? About the yes? So what I mean by the word is here we release photons, and then we don't touch them here. We don't interfere with them. So they are behaving by the nature. Huh? So this is quantum world. Very appropriate explanation of quantum world would be they are full rounds. They are very good. Let you observe, do not interfere with the quantum world, so it cannot be played by the quantum element. So here we release the particles into something their own nature, and then we read it out. Okay. You have more. Tell me. This is very easy. I'll explain you. There are some materials, like molecules, which can get excited by vibrations, for example. You know, molecule is it's a core and a lot of electrons. And when they're in the relaxed state, they can be there forever. But when they receive some energy by photon, thermal energy, whatever, one of these photons can get excited, and then it makes larger rounds. It makes party. Huh? But this is not good for the molecule. So it will leave it for a while, but then it will say, "Come on, calm down. Let's stay calm." No? And then this photon will have to go back to its ground state. So it will have to release this extra energy. And it's doing the release by emitting a photon out. In this way, a single molecule isolated, excited, and then it will release a photon. In this way, you have a single photon emitter. Yeah, these photons, let's imagine the source here. This one emits photon out. This photon will go, straight. And then you have these 6 holes immediately after detectors. And one of the detectors will see the photon. If it will not go to South America. Sure.
Yeah.
I could not plot 6 of that on this.
Oh.
Imagine, there are 3 more. Let's go to classical computers. This is a typical laptop. This technology, it's somehow compared to the quantum relatively simple, but the level at which we reach in these 50 years, it's very advanced. You will see later. So these computers, laptop computers that we have on your laptop, the price is, let's say, €1,000. But if you open it and you check how it's done, you see that the technology is it's much more advanced. So it's much more advanced than buying 1,000 pieces of bread. No? So the technology level is so high because we are developing this for more than 50 years. And these computers are very powerful. They can do many things. This is, for example, just the laptop, but there are powerful computers, servers, farms of servers. And there is a lot of information going through these computers. They are doing a lot of calculations, a lot of good that we can live in such a comfort today. But what's behind these computers? You know that these computers, they work just with zeros and ones. No? So what does it mean? Maybe you can imagine the world of classical computers like it was in this movie, no? So information is coming, but the true information which is kept in these computers are just zeros and ones. Because these classical computers, these are just boxes of switches. A switch can be in on state or it can be in off state. So this is the switch in on state and this is the switch in off state. Now I will bring you more insight. How is this done technologically? So this part, this switch is the most important part. It's not switched on by hand, but it's switched on electronically. So you need material which can do this switching. And today computers, they have a lot of such switches. For example, the newest Apple Core computer has more than 60 billions of switches. So you can imagine this is quite a lot, no? So the technology is here. So this is a silicon wafer. And on this one, this wafer, we make transistors. You can check it around. On top, you can see the lithography process. And with this one, we can make transistors. So the transistor, this was the first transistor in 1947, long time ago. And the current was flowing from here. This was the thing. So by this one, you control, was flowing through this. This part of material was so-called semiconductor. This part was on or off, and it was controlled by this. Can you see this part here? So the idea of these electronic switches is that you have a material which is or isolator or conductor, a metal, not metal. So it sometimes it conducts, sometimes it doesn't conduct. So it's called a semiconductor. And how you convince that this material will conduct? A big question. So you do a trick. You put a thin layer of isolator and then you put an electrode on top. And then by applying a proper electric potential to this electrode, you will see how it works. So imagine, if you wish that this lamp will light, then we need to bring this current through this material to the light. Here, there is another part of circuit which I drop it out. So to convince this material to let pass through this part, this charge, we will connect a battery of opposite charge to the metal element. And once we connect this is some metal, minuses will go in, and these minuses will attract pluses. So these minuses will convince this material to become conducting, and the charge will flow to the bulb, and the bulb will light. So this is the idea of the conductor. And if we rotate the battery, the pluses will not let the plus go. They will repel. Now the dimensions. So what's the minimum distance here? This one is a few millimeters large. Nowadays, I said. So this is the scheme graph showing the years bottom, and here showing the number of transistors in a computer chip, computer core. And you can see they started with 1,000 chips, 1,000 switches in the 70s. And then it was just increasing for years and years. Now we are here. So we are over 50 billions of transistors in just a small piece like 1 centimeter. So it's very, very small. How small it is, we can now think. So each transistor now is thick 2 nanometers, 2 to 5 nanometers. How much is this? Nanometer is 1,000th of micrometer. Micrometer is 1,000th of millimeter. So imagine you take 1 millimeter and you divide it by 1,000. Get 1 micrometer. Then you take one that piece and you divide by 1,000. And you get 1 nanometer. So this is now the size of the each this electronic switch. So are we already using quantum computers because they are so small? We are not, no? Because still this part, semiconducting part, does not conduct a single electron, but it conducts a lot of electrons. So it's still behaving like an average. Yeah. So that's why today classical computers are not quantum computers. And so it can be only conducting or not conducting. So they are only having 2 states, 0 and 1. On the other side, if we would be able to use a photon, then we could exploit its quantum nature. And each photon is coding the information or going either through this gap or going through this gap. So when we release a photon here, the photon is not in one, let's say this is 0, this is 1. The photon is not in just this case state, or just in this state. When we are releasing it, the photon is in one of these 2 states. It's in both states. So the main difference between quantum computers and classical computers is here information can be just 0 and 1. But here the information is both 0 and 1. We don't know. Okay? Since we measure it, we don't know. Okay. Now I'd like to have a break of 5 minutes because I think you have a lot of questions to me now, and I need to go to toilet. Just okay, now let's move to another. This part now will be more mathematics. I hope I will not scare you away or lose you. And stop me if you have questions. No? So let's say quantum bit is 0 or 1. So the switch is on or off. And then we will label them like using this kind of this kind. No? So a bit is a piece of information in classical computers, and it can be 0 or 1. And with these 0 and 1s, we can write all numbers, all text, all movies, all books, all computer games, and whatever. Then, for quantum bit, we must invent something which is 0 and 1. And we call this superposition of both states. It is 0 and 1. We don't know. If you don't know something, then you start to speak about probability. No? How probable is that I will win the lottery or not? No? So we don't know whether it's 0 or 1. Something, it's or 0, 1 or 1. So this is our qubit. The piece of information in quantum computing is called qubit. And it's superposition of both 0 and 1s. And all the calculation we do through, we must do it with probability. So if you write those classical like this, we must write the qubit like the superposition means sum first one and the second one. And these coefficients here, A and B, alpha and beta, they are just the probability coefficients. So if there are probability coefficients, if you square them and sum together, you get 1. Oh? Because the total probability is 1. Any questions? No. How to plot the qubit? You might sometimes see this representation, which is called the Bloch representation, Bloch sphere representation of qubits. So they call it the qubit is or 0 or 1 or 1 of these two. They are the coefficients and of the angle theta and theta. So qubit is presented by the sphere. So the state is somewhere in this sphere with the radius 1. And if it's a pure zero, then it's on the top. If it's pure one, it's at the bottom. Okay. So comparing these two, classical ones, 4, 0, or 1, the qubit can be everywhere on the sphere. Yep. Then what physically in nature can we use to do quantum computing? Before I was speaking about molecules, no? You can excite molecule. So this is one kind of possibility that you store this quantum information. But if you go to Wikipedia, you will see this list of all possibilities. And I will just read some of them. Like I was speaking about photon. So we can use photon as a quantum information. You can use electrons. You can use nucleus of atoms. Some strange pieces of crystal where you store optical waves. Quantum dots. Logical systems. I'm here in this area when there was heterostructures where you can use the two-dimensional materials. So common to all these systems is that you need to work with very low temperatures, because imagine you put photon there and everything is waving like this. This photon will be disturbed, will be flipped around, and you will lose the information. But if you cool everything down so the nature will not shake, then the photon there will stay for a few seconds. And this is enough to do quantum computation. I'm speaking very roughly here because we don't have time to explain everything. But I want to pass to you the feeling of what's important in this world. You know that if you hit material, then the atoms start to shake. No? But if you have information on such an atom and it's shaking a lot, it will flip around and you will lose the information. So you need to cool down to minus 200. You know what is the absolute zero? Yes. So you need to cool down to 0.1 meter. Minus 173.04. Okay. And this is still expensive nowadays. So just a few quantum computers are available. Okay. Now I would like to show you how to make a quantum program. Okay. This might be a little bit boring for you. I will go quickly through. If anyone wants, stop me and we can discuss later. So imagine that we wish to make a quantum computer of this experiment. It's similar to the one which we were seeing before. So we have one semi-transparent glass and you have another one here. You have two mirrors. You can shine here, going to this detector. If something reflects, it will go to this mirror, it will go to this. But it might also reflect here and go to here. This one might go here and here. So the question is, what will be the intensity of light here? What will be the intensity of light here? To safer. To say it's more. I will show you the experiment now. So again, this is the source, this is the gate, and these are the measurements. Say this one is right. Okay. To say that this one is equal. Any more guesses? Who gives more? I take bets. let's say we will label. If they will come to this detector, we will call this is the 0 part. Yeah, 0. And if they come to this detector, we'll say it's 1. And this is 1. Yeah. Now let's see the experiment. So here we are doing the experiment, and here we are playing the trick that we are blocking one way, like we did with the piece of paper. So you see when it's blocked, how it's blocked, and we get them to hold the detectors. Once it's open, then we get the mode to be. This is the Max Zender experiment, which was a big piece of home of physicists for a while. No? So what mathematics you need to reproduce such kind of behavior? So if both parts are open, then the detector will not show anything. Everything will be on this detector. Because whatever it will be split here, it will recombine here. Okay, no. So the stops, when they come out here, they are only the one state. And then if we wish to reproduce the behavior of this experiment, then we need to take the matrix like this and say that this beam splitter or this semi-transparent glass makes this operation on this kind of vector. Okay. So after the beam splitter, so at the exit of the laser, this is in 1-0 state. After the first beam splitter, it becomes a little bit in the first state and a little bit in the second state. I is complex. But you have it something in the first detector and something in the second detector. I mean, you have it. You have the probability to get. And then once again, multiply by the second splitter. So you take this state, you add it here, you multiply by the beam splitter, and you get just the So if we take such mathematical operation as a beam splitter, then we can reproduce this experiment. Yeah. Remember it because later we will put this with the elements which we have in a quantum computer. Now, how we do it in real quantum computer? So Qiskit is the quantum computer of IBM, which is available to people, for public. So you can go to this web page, which I'm giving it there, and you can register there. Then you can enter, and you will be able to program these quantum algorithms. Here I will show you how it goes. So you log into the web page, then you register inside, and then you launch this quantum composer. Like this. I did this, it requires some time, that we send your mail back to confirm and so on. So this is a quantum composer. Quantum composer, the main part is here. This is the 2-bit lines. This quantum composer now at the moment has 2 2-bit lines. 2-bit line means, for example, each photon is 1 qubit. So here we are doing experiment with photon stuff. And then here in this line, you assemble the elements which you have here. By playing with this composer, you can learn about different elements. But it's not the aim that I teach you now how to do it. The aim is that we take just a single photon and then we take appropriate elements there. By the way, this is the spherical representation of qubit. And here you have the probability of the results. No? So if we take a single one and then you measure it again, the probability to be 0 and 1, it's 50-50. Something like this element, it's very similar to the one which we had before. Do you recognize it? Our beam splitters of the semi-transparent glass have II here instead of 100. So we cannot use directly this element here in the gate to computation. We need to convert it that there will be complex numbers on the diagonal. And we do this by the phase change, this one. So this is the math. So we combine so this is the beam splitter. And instead of using this one, we make it out of two phase changing. And one with the operator. So if you calculate these together, you will get the same. This is the beam splitter. So it means we take the single photon, we put these three elements together, and this represents the first beam splitter. And then after this one, we put the second beam splitter. So we just drop it here, second beam splitter, and this is the Mach-Zehnder experiment. Okay. At the end, we measure it, and you see the probability is only on a one detector. Okay. So this is done in this composer. Now we need to launch this program on a quantum computer, which is not so trivial because everybody are playing with this stuff. So what you do, this was done in July for me. And I was in the queue. So I submitted to one of the quantum computers. By the way, this was this quantum computer. The name was IBM Quito, and I don't know where it was. Maybe by the name I would say or in Spain or in Mexico. And then I was waiting a few days. And this was the outcome of my computing. How I did? I simulated 1,000 photons. And I was checking the probability of measurement. And you see, most of them, almost 800 photons, came into the state 1, which is theoretically the one which should be the only one. But there are some like more than 145 came into the state 0. So these are those which violate this law, Mach-Zehnder experiment. Oh. Why is this so? This is so because this is quantum world. If I would run millions of photons, then this ratio would be smaller. But at the moment, these quantum computers are full of errors. And that's for a lot of problems comes also because of the errors in the computers. They are not so technologically ready like the classical computers, but they are still in the development. Okay, so here you see. It took me wait. Because there are some problems. Like, for example, you take a medicine, no? And this medicine is some molecule, strange. And this molecule will come to your body where you have some other molecules. And you wish to calculate, you wish to understand how they interact with each other. If you wish to do it in a classical way, you need to take a model of a molecule, model of this molecule. Then do a lot of calculations, modeling. In quantum computer, just take a molecule, take another molecule, and you put them together and you see what it behaves. Or you take atom which behaves similar to the molecule, and another atom which is similar to this molecule. You do a lot of such operations on it. So you make a similar problem than to putting these two molecules together. In a classical computer, it will require several years to calculate such a problem. With this one, when it will have enough qubits, enough lines, because these computers of IBM, they have 5 qubits. You can simulate 5 photons. When they will have enough, they could do the calculation much faster than possible. Actually, some calculations are even not possible to do it in a classical mode. You ask? That was one that have a one bigger equation. Start to solve it. One change in input parameters. Let's get difference out. That will better can be just forecast clouds. Just noise. But with quantum computers, you can solve nonlinear equations. So that's why people develop. Yep. So that's all from my part. If you wish to know more, study by yourself. Okay. Thank you for your I always welcome. You can also write to me my email. Very interesting.